Welcome, everyone. Thanks for joining us for today's webcast. My name is Grace Zhang. I am a research manager at the Water Research Foundation. Today, we're presenting the Legionella Management and Guidelines. Since September, the Water Research Foundation has hosted a three-part webcast series on the Legionella. This is the last webcast in a series of the three webcasts. If you would like to access the on-demand webcast and the presentation slide, please visit our website and click the resources page. Then you will be able to access the recorded webcast and a slide. I would like to introduce our speakers today. Well, we're planning to have a Dr. Catrubo to have for the opening remark, but unfortunately, he is not able to join in our website or webcast today. So our apology for this. Our first speaker is Dr. Laura Cooley. Laura is a medical epidemiologist at CDC, and she is devoted to the Legionella surveillance and the surveillance, response, and prevention work. Our second speaker is Mr. Bill Pearson. Bill is president of the Pearson Consulting. He is the vice chair of the ASHRAE Legionellosis Committee and the chair of the Cooling Technology Institute Legionellosis Committee. Our third speaker is Dr. Clarissa Lucas. Clarissa is coordinator of the CDC Elite Program. She has participated in investigation of over 40 outbreaks of Legionellosis or unexplained respiratory disease and conducted dozens of environmental studies. Our fourth speaker is Dr. Dave Dzwolski. Dave is the section chief of the Water System Control and Analysis in the Bureau of the Water Supply Protections at the New York State Department of Health. He participated in the development of the New York State Regulation Part 4, Protection Against the Legionella. Our last speaker is Dr. Mark Richevalier. Mark is the principal and a manager of the Dr. Water Consulting. He had worked for the 30-plus years with American Water before he retired. He currently serves on the Water Science and Technology Board for the National Academy of Science and is a member of NAS Legionella Work Group. Just a little housekeeping before we get started. Today's webcast will last 90 minutes in total, and the webcast is being recorded. The recording and a PowerPoint slide will be posted on the Foundation website. If you have any questions during the presentations, please type them into the question box on the lower left of your screen. We'll have a time for the question at the end. Immediately following the webinar, you will be directed to the follow-up survey. Please take a moment to answer those questions. Before further ado, I'll turn the time over to the Dr. Cooley, and please take it away.
Great, thank you. So I am going to be talking today about the epidemiologic context for the next two presentations. I have nothing to disclose, but I must state that the findings and conclusions of this presentation are mine and not necessarily those of the CDC. Cases of Legionnaires' disease have been reportable to CDC since 1976. Here we show just 2000 to 2017, where the rate of reported cases increased 5.5 times. From 0.42 cases per 100,000 people to 2.29 cases per 100,000 people. While diagnosis and rates of reporting have improved over time, this curve still likely represents an underestimate of true burden. So here we have a heat map, which shows rates of Legionellosis by jurisdiction. So the darker the color, the higher the rate. This is 2007. And notice that there's that darker area in the mid-Atlantic to northeast region. We refer to this informally as the Legionella belt. So are there differences in rates due to differences in disease or possibly due to differences in testing practices and diagnosis? You know, it may be a combination of both, but it's definitely a pattern that has been consistent over time. So here's 2012. Note that the rates of reported cases are increasing. So yes, in the Legionella belt, but also elsewhere. And here again, you see really the whole country is getting darker. This is 2017. To be sure we're on the same page, really to set up the next two talks, I wanted to give a quick review about how we get from Legionella to Legionnaires disease. So Legionella lives in fresh water, but in fresh water there are insufficient quantities to cause disease. It's in large, complex human-made water systems where Legionella can amplify depending on the conditions. So factors such as warm temperatures, stagnation, scale and sediment, biofilm, protozoa, absence of disinfectant. To cause disease, Legionella must then be aerosolized and then transmitted to a susceptible host. So not everyone who gets exposed to Legionella will get sick. It's more likely people who are 50 or older, current or former smokers, people with weakened immune systems, or other chronic diseases. So what do we know about source attribution? In 2016, CDC did an analysis of 27 building-associated outbreaks from 2000 through 2014. And found that the most common settings were hotels, followed by long-term care facilities and hospitals, and that the most common sources were potable water, such as associated with showers and faucets, cooling towers, hot tubs, decorative fountains, and industrial equipment. Once a month, CDC issues a report called Vital Signs on major health problems that should be preventable. The goal of Vital Signs is to raise awareness, to issue a call to action to various audiences, such as the general public, healthcare staff, public health, and CDC partners. With the rise in disease rates, Legionnaires' disease became part of the Vital Signs program in 2016. Our first Vital Signs in 2016 focused on the importance of water management programs in buildings that increase risk for Legionella growth and transmission. The basis for this was the analysis I just mentioned, which was published as an MMWR, and the take-home message was that most problems leading to outbreaks could be prevented with effective water management. So here's a list of guidelines, standards, and protocols used to address primary prevention of Legionnaires' disease through water management. For us, the real game changer here was ASHRAE 188, released in 2015. Bill Pearson and Clarissa Lucas will be talking about ASHRAE 188 in more detail. Requirements for water management programs in the United States are currently limited to a few jurisdictions by state or local law, which you will also be hearing about later, and then also by CMS. So in 2016, CDC translated ASHRAE 188 into plain language for wider audiences in the form of a water management program toolkit. It walks through the framework for creating and maintaining a water management program according to the principles outlined in ASHRAE 188. And with that, I will pass it over to Bill Pearson, ASHRAE member and Vice Chair for the 188 Committee, who will now present on ASHRAE and the importance of standards and guidelines.
Thank you very much, Laura, and a nice segue into my section, which is actually titled ASHRAE and the Importance of Standards and Guidelines. And wow, I get 10 minutes to cover something that I normally talk 60 minutes to 3 hours on. So I do need to get started. No real disclosures here or disclaimers. I am the Vice Chair of the SSPC ASHRAE Committee for 188. And I head their Speakers Bureau, so this presentation is on behalf of ASHRAE. And I also serve as a liaison to the ASHRAE organization from the Association of Water Technologies. So with that said, and again, a lot to cover in 10 minutes, this was the outline. We clearly want to cover some ASHRAE 188. We're not going to talk about the whole standard. But more importantly, I'd like to give some feedback from my experience, certainly over the past 3.5 years since ASHRAE 188 was published in June of 2015, in terms of speaking engagements and actually real-world situations with water management plan implementation. And we cannot forget about a guideline that's in revision, that's been around for longer than the ASHRAE Standard 188, and that's the ASHRAE Guideline 12. So I kind of narrowed everything down into, I'd like to talk about the changed and the changing landscape and focus around Legionella in building water safety, particularly since ASHRAE Standard 188 was published. And then again, give feedback from my engagements dealing with those, and we'll finish up with the ASHRAE Guideline 12. So Laura did provide a great segue we have these two documents, and you'll note that we don't just have ASHRAE Standard 188-2015. That is when it was released, but there was a recent republishing of that standard, and so it's technically now ANSI ASHRAE Standard 188-2018. That's because this standard is a standard under continuous maintenance. That's a formal program by ASHRAE where it can be updated much quicker instead of the 5-year cycle. In fact, when you have the standard, when you purchase the standard, there's a form on the back of the standard that you can render, comment and suggest changes, from day one. So this was done in August of 2018, this year, and it primarily was to really reinforce the code language so it would be enforceable when adopted by codes. The second document that we will get to is the existing Guideline 12-2000, meaning it was published in 2000. So that's 18 years ago. This guideline has been around for a long, long time. It's ASHRAE's number one, product in terms of this information dissemination. And its title is Managing the Risk of Legionellosis Associated with Building Water Systems. So you can see how it kind of fits really nice with the Standard 188, which is Legionellosis Risk Management for Building Water Systems, and then a Guideline 12 that can talk more about some prescriptiveness that's not in the actual standard on managing the risk of Legionellosis associated with these buildings. So a quick special note on the very front page of the ASHRAE Standard 188, a question that's almost always invariably asked. Compliance with any ASHRAE standard, and with this standard, is voluntary. It's a voluntary consensus standard. Compliance with this standard is voluntary until and unless a legal jurisdiction makes compliance mandatory through code adoption or legislation. Certainly we saw that in New York City. Just as ASHRAE 188 was being released in the summer of 2015, New York was in the midst of an outbreak of Legionnaires disease that ultimately, resulted in some 18 deaths and 160 people ill. So it got a lot of attention. And so let's just summarize real quick what ASHRAE or the standard is about in a nutshell, as they say. Compliance with 188 requires owners, and the responsibility of the onus was really clearly from the standard put on the owners, managers, to follow a risk management process. So it's a process we're talking about to establish a team with assigned responsibilities, and then, very important, to have, practice, audit, and maintain a water management program. Thus, we have the acronym, a WMP, Water Management Plan, standing for the Water Management Program, to deal with Legionellosis risk management in these water systems. So you can find that in the ASHRAE 188 standard in Section 6. We're not going to go in at all into it, but we have a single figure in the standard, and it talks about the essential elements of the risk management process. And again, I want to reiterate that the ASHRAE Standard 188, a lot of people thought, well, this was going to tell you exactly everything you had to do and know, to deal with Legionellosis and managing it. It's really a process, a risk management process, and is not prescriptive. A lot is left up to the team to make those decisions. Thus, you're going to end up relying on other guidelines and information on the subject matter. But you can see the process here, forming the team, describing the water systems, doing an analysis of the building water systems. Where can you control Legionella in these systems? So the fourth part, control measures, are very important. Then you have your monitoring, your corrective actions in 5. And very importantly, you have your confirmation, verification, validation part of the standard process, and then everything requires documentation. But what I want to talk about is how our landscape has changed. Along with that outbreak in 2015, intense investigations and work, particularly now that a standard was out, and New York actually adopted it in first emergency regulations and then into their law, New York City and then statewide. And the CDC came out actually in 2016 with what they call, and Laura mentioned it, the CDC Toolkit, a very, very nice document, and it was updated a year later in June of 2017 to what you see here. And you can see it from the title, Developing a Water Management Program to Reduce Legionella Growth and Spread in Buildings. Along with that, kind of what I call the sister document, is the vital signs that Laura also mentioned that brought into recognition some incredible statistics and data generated by the CDC. We talked about the 9 and 10 of their investigations showed that a water management plan could have helped prevent the outbreak, and the vital signs. In 2017 here, we find out that it's not just 1 in 10, about 10% of legionellosis is fatal, but in the healthcare environment, if you catch Legionnaires disease in a healthcare setting, 1 in 4 or 25%. So a lot was coming out. And then in 2017, we got the CMS directive. And this was extremely important in terms of advancing actually the requirements, or I don't want to say interest, but what people were now doing with respect to coming out with water management plans. So the Centers for Medicare and Medicaid Services put this directive out. It was immediately effective that June 2nd, 2017. There were a couple of revisions. In fact, one just recently, this July of 2018, kind of just actually coming out and giving some clarifications. One clarification that needed pointing out because there were some misinterpretations with the directive, and that is Legionella testing mandatory by CMS in their directive, and they clarified that CMS does not require water cultures for Legionella or other opportunistic pathogens mentioned in the memorandum. These testing protocols are at the discretion of the provider. So, bottom line though, the CMS directive says you must implement a water management program that considers the ASHRAE Standard 188 and the CDC toolkit. And this impacts the long-term healthcare facilities and other healthcare institutions, those that require certifications from the CMS. So it is an authority having jurisdiction, if nothing else, the purse strings that it controls. So I said that was very important as a water treatment professional. I saw an immediate impact on these healthcare facilities calling up their water treaters saying, we need now to comply with this CMS directive. It's a CFR, Code of Federal Regulations. So the point here is that Legionella has everyone's attention. The acronyms, can go on and on and on. And it was, very important that we have, this going on. I need to back up real quick. So I think one of my slides didn't show, and this was the about the NASEN, the National Academies of Science and Engineering and Medicine. They formed a water treatment committee the 1st of 2018. It's called Management of Legionella and Water Systems. And they met, as you can see here in this short graphic, 4 times. Their initial meeting, the 2-day meeting in February, they met in May, met in July, met in October. So again, what we're seeing is this incredible attention from organizations, from departments of public health, all about managing legionellosis in our building water systems. And so I would like to mention, we don't have a slide on it, but the ASHRAE Guideline 12 is under revision. In fact, it's in its 3rd public review, and it ends December, I think, the 17th. So you still have some time to make a response on that review. And it follows an ANSI process, although it's a guideline. So it's quickly coming to completion. ASHRAE will meet in January, and we hope to get the 3rd public review responded to. And then that document, as I said, will be out to fill in the gaps associated with the Standard 188 and deal more prescription and guidance for that document. I'll finish up by a few words that I feel are important about that state health officials really hold the keys to Legionella prevention. I'm not a regulation person, but ultimately I think they're going to be needed for facilities to implement water management plans. And regulations that are based on a standard can be established, very quickly, as we saw in the case with the CMS. CMS could not have established the requirement so simply or quickly without a standard, the ASHRAE 188, to make a reference to. And finally, the ASHRAE Standard 188 is the best standard on which to base Legionella regulations, in my opinion, because it's here and ready. Waiting for a better standard will cost health and life. It has a continuous maintenance process, as I mentioned, for accepting and considering comments and making changes. And it can outline the essential elements and framework for these water management plans, whereby the states then can put in their specifications, procedures, performance, and criteria. So again, the wow part of my talk was 10 minutes to cover a lot of information. And at this point, I'll be able to pass it over to Dr. Clarissa Lucas.
Thank you very much, Bill. So I just wanted to give a little bit of a overview of an approach to water management as we kind of gave it in the CDC toolkit. And like Laura, I am going to say that I have nothing to disclose, though I have realized now I should probably mention that I am a voting member of SSPC 188. However, I'm speaking more along the lines as elite program coordinator right here. And again, the findings and conclusions are to the author and not CDC. So I think Bill gave us a really good overview of the elements of a water management program. In our toolkit, an excerpt of which is shown here, we go over the same 7 steps of establishing a team, describing your building water systems, identifying areas where Legionella can grow and spread, deciding where to control that, establishing interventions if control limits go out of whack, and to make sure that the program runs effectively and that you're documenting everything. I think a lot of people kind of get hung up on the validation and verification, the steps 6 and 7, when really I think from this slide, the important part, let's see, there we go. The important part is really this continuous program review. It is not a set it and forget it plan. You really have to go back and look at your logbooks and make some command decisions. I think, as Laura said, a criticism of the toolkit was that it's not really a template that you can just take and apply to your building. We can't possibly know as much about your building water systems as you can. So Standard 188 and our toolkit try to inform you of the science while giving you the flexibility to create a site-specific plan. What we hope is that your daily activities there we go, will be the bulk of what your water management program contains, and that is identifying those control points and applying the control measures and monitoring the limits. So on the right side, if everything's within limits, go on about your day and pat yourself on the back. If on the left side something is outside of control limits, you have already determined what sort of corrective actions you can apply to bring things back within limits. So we hope that this is, again, the bulk of your water management program activities. But as I said, a lot of people kind of get hung up on steps 6 and 7, verification and validation. So taken direct from Standard 188 are these definitions of verification being initial and ongoing confirmation that the program is being implemented as designed, while validation is initial and ongoing confirmation that the program, when implemented as designed, effectively controls the hazardous conditions throughout the building water systems. A question we often get at CDC is, what should my target be? Well, the official CDC position for testing for Legionella is still no recommendation. We have some very key suggestions for what to do in cases of disease, but in validating a program, if you decide to test for Legionella, the program team shall establish procedures to confirm that the program effectively controls the hazardous conditions throughout the building. So you see that the program team has a lot of responsibility, has a lot of power, and so with great power comes great responsibility. Just to reiterate what testing is, testing is conducting a planned sequence of observations or measurements of physical, chemical, or microbial characteristics of water to assess weather conditions throughout the building water systems meets the goals set by the program team. Not set by CDC, but set by the program team. So just to make sure that in my elite program coordinator capacity. I know many of you kind of take that to be kind of the de facto baseline proficiency testing, and this is where I wanted to get it out there in the world that we really designed the elite program to be a resource for CDC, to give us a list of labs that we can partner with during and immediately after investigations. But that being said, we recognize that it can be a good way for these environmental laboratories to demonstrate proficiency in traditional culture. But I just want us all to be on the same page about some of the limitations of traditional culture and what happens with your sample in a testing lab. So what's shown here is a vacuum concentration setup where we can filter a liter of water through a small filter that will catch the bacteria, and then we can concentrate it in a smaller volume. We need to do this because Legionella rarely, if ever, occurs in the environment in pure culture, and it's usually, even during the course of an outbreak, in low concentration. So we have to do something to enrich for the Legionella so that we can detect it. And I just wanted to show you an example of a single sample treated in 3 different ways. In the first instance, we have Legionella plated directly on an unselected plate, and you see that it's really overgrown. So your testing laboratory, if this were the result, would report Legionella not detected. Hopefully they would also tell you that it was not detected because it was overgrown, so you would know that about your water quality, but still, the final result would be not detected. In contrast, if we treat it in a different way, concentrating it and acid treating it and plating it on semi-selective media, we can get a single colony in this case, which, due to our formulations, would result as 0.1 CFU per mil. And yet a third way, a GPCV direct and acid treatment, we were able to get Legionella in pure culture. Thereby the result would be reported as 120 CFU per mil. So I hope you can see how a single sample within a lab or between different labs can give you different results. Chances are they're going to give you a positive yes, no, but the enumeration may be a little tricky. To look at it another way, what's shown here is the cumulative results of all elite program labs entries between 2010 and 2014. So this was about 289 labs in 7 different countries doing at least 2 different tests per year. And what I hope you take home from this is that whether the Legionella is in pure culture or mixed with things that look like Legionella, our elite labs are pretty good about giving you a yes, no, it's their answer. They very rarely give you a false positive. 97 to 95% of the time, it's a true positive. Where we run into issues is enumeration, and we see that whether the samples are mixed or pure, we get at least a 1.5 log on average underestimation of the true count. So I just wanted everybody to be on the same page about kind of the limitations of traditional culture. Now, of course, there are other detection methods coming out. Liquid culture with bacterial enzyme detection is a new one. I believe the trade name for that is Legionella. We have nucleic acid-based detection methods and antibody capture and visualization. I think those are the main alternatives to traditional culture on solid media. And they all have their pros and cons. Oftentimes they have, especially with PCR, you may have increased sensitivity or faster turnaround time, but they can also have some limited specificity, like they might only detect a single species or a subset of species. And of course, again, with PCR, you might have some issues with live-dead discrimination. But again, that is not necessarily a problem for a program team as long as they understand why they're testing and how they're going to interpret the results. So just to kind of summarize what we talked about, water management, we hope you know by now, is a dynamic process. That water management programs should be very site-specific, which is why we at CDC are very reluctant to put out any kind of templates. The program team has a lot of power to decide validation criteria, control limits, within the context of what's scientifically valid, and we will do our best to put that out in the world there. Legionella test results may inform your validation criteria, but they are not necessary. And Legionella test results are not a substitute for monitoring water quality. Again, we hope that that is the bulk of your water management activities. And periodic program review is crucial for effective management. So that's all I have for right now. I'm going to turn it over to Dr. David Zawulski.
Thank you, Clarissa. The material that's to be presented today will cover the current version of the regulation, Part 4, Protection Against Legionella. In today's presentation, we'll briefly cover the regulatory requirements of Subpart 4-1, which pertains to cooling towers, and Subpart 4-2, which addresses potable water systems in healthcare facilities. We'll also cover a little bit of guidance that's available too. So the first thing we'll cover is the section on cooling towers. The key elements: all cooling tower owners are required to register their towers in the statewide registry and to update their sampling, inspection, and certification information at intervals not to exceed 90 days while the tower is in use. So if a tower has been entered into the registry but the sampling or other information is out of date, the tower is considered to be non-compliant, and enforcement actions may be taken against the owner. Bacteriological samples should occur at intervals not to exceed 30 days, although many towers routinely sample much more frequently. The owner can report these data as they are acquired or less frequently, as long as they report at intervals not exceeding 90 days. The most recent sample collected and analyzed should be reported at the 90-day interval along with Legionella sampling, and most people do that along with their inspection dates. So the key components are shown up on the slide with the green brackets, that you have to have a date for an inspection, you have to have a date for your last BAC-T sample, a date for your last Legionella sample, and a date for your annual certification. And this slide just shows a distribution of the cooling towers in the state. You can easily pick out the larger cities from west to east: Buffalo, Rochester, Syracuse, Utica, and the Capital District. There are about 4,000 towers across the state, and the inventory changes weekly. Our metropolitan area office in the southern section toward New York City covers Long Island and the counties north of New York City. There are about 7,800 towers there, but about 5,000 of those are registered in the New York City registry and are located in New York City property. So that whole area is essentially a blur because of the high density of towers. One regulatory requirement of Subpart 4-1 is the MPP, or the Maintenance Program and Plan. The suggested elements of the MPP are presented on the slide, and the process diagram is pretty important because it gives the regulator and anyone unfamiliar with a particular system an instantaneous idea of sampling and control locations. The MPPs we've seen are of variable quality. Many vendors have produced very good plans, and we use them as models, but many plans are just essentially so-so. Appendix 4A of the regulation, which is part of Subpart 4-1 and the cooling towers, outlines the response actions for the different levels of Legionella once they're found in the cooling towers. At a level less than 20 CFU per mil, the owner should maintain the treatment program and monitor according to their maintenance program and plan. At a level greater than or equal to 20 CFU per mil, but less than 1,000, requires some online disinfection and resampling in 3 to 7 days. Most facilities will resample in 3 days so that they can move on with their disinfection plan. At a level exceeding 1,000 CFU, immediate online decontamination should be instituted, and the local health department should be notified. That is a regulatory requirement. Online decontamination means the dosing the recirculation water with a halogen-based compound equivalent to at least 5 parts per million free residual halogen for at least 1 hour. And the cycle of disinfection and decontamination and retesting should be repeated until the Legionella cultures return to less than 20 CFU per mil. And one note here, Legionella culture analysis must be performed by an ELAP-approved lab, Environmental Laboratory Approval Program. It's a comprehensive regulatory program, and to be certified by ELAP, other requirements need to be met in addition to proficiency testing. ELAP certification requires a laboratory have a qualified laboratory technical director and a quality assurance officer, have an appropriate standard operating procedure manual, and submit data demonstrating that staff are capable of performing testing. That is the demonstration of capability. And they also have to have a successful on-site inspection. So those are key elements. The next section we're going to talk about is a really brief summary of Subpart 4-2, which refers to our healthcare facilities. Now, there's a little bit of a definition that's required here. it refers to buildings that provide inpatient services, lodging, board, and physical care. It does not apply to administrative buildings or outpatient services. So basically, it's overnight stay, some sort of board, and some kind of physical care. One requirement of Subpart 4-2 for healthcare facilities is the environmental assessment form. It's DOH Form 5222. It was actually developed back in 2005, and it's been implemented since 2009 and then folded into the requirements of Subpart 4-2. The environmental assessment must be updated annually or under certain conditions, including completion of construction or repair activities that may affect the potable water system. It is used to help identify possible vulnerabilities within the building. This is just the cover page of a 12-page document that you see on the screen, and we call it the EAF. The form requests information on building components such as all components of the hot water system, water temperatures, chlorine residuals, storage tanks, and ice machines. And basically what it does, it helps us and the user to determine the vulnerability of the building to Legionella colonization and amplification. Another regulatory requirement of Subpart 4-2 is a sampling and management plan. That's nothing more than a water management plan. It just has a different name in our regulation. Plans for covered facilities have been implemented since December 2016, and new facilities must adopt a plan prior to providing services. Sampling and management plan must be updated annually and following conditions as mentioned just previously that include things like constructions and major repairs. And likewise for Subpart 4-1, there's an ELAP requirement for any culture that is taken. Now let's give an example of tracking compliance and what we've seen. These bar graphs, the blue are the recoveries that we're seeing from all of our counties, and the red is what we're seeing from our district offices, which manage the environmental health programs of counties without programs. And the big difficulty here is dealing with an owner-controlled registry database. They actually enter the data. So in order to keep it current, we have to send out statewide email blasts. Sometimes we target specific counties with temporarily low compliance numbers. Then we target specific owners if necessary. And then the last thing we would do is send out non-compliance letters and then prepare for enforcement and an administrative tribunal. This is all done in cooperation with our regional and district offices as well as our local health departments. So one little note, we probably could add about 10%, so we're around 50% here, probably can get up to 60% for these compliance numbers if we took the facilities we have in our registry for New York City. Their determination of compliance is slightly different, and they don't enter dates into a registry. Therefore, they appear non-compliant even though each tower is visited and compliance issues are determined on-site by city staff. They've got a very comprehensive program. So let's take a real quick look at a slice in time. This puts the previous slide into perspective. From 2015 to 2016, we are transitioning from emergency regulations to permanent regulations. And then compliance efforts were ramped up in the period of 2016 to 2017, and our baseline compliance in 2017 was around 30%. Compliance and enforcement efforts were ramped up in the period of 2017 and 2018. And the table shows a slice in time for November in the last 2 years. It's a period when, with simple tower shutdown date, remember it's a date entry that makes them compliant, compliance should go up. And after an email blast reminding folks to enter their shutdown dates, we saw a 10-point increase in overall regulation compliance from our summer 2018 numbers and a 28-point increase from 2017. And there's those 4 key regulation compliance requirements. If we take a look at the cooling tower exceedances that have been reported to us, the maximum in any month was 10 samples, and in any given week, a little over 80 in the current season, but there's no way to determine who is actually reporting and who is not. As of November, we could add 10 to 15 more exceedances than have been reported. because this slide ends on September 7th, 2018. So we've done some partnering, and in this particular instance, we did partnering with the federal government, and we've had discussions with CDC and GSA. In states, in New York State in particular, there's a federal exemption, which means they don't have to follow state regulations, but usually there's some sort of cooperative agreement that says we'll do that. And GSA adopted Subpart 4-1 for federal facilities, but under the advice of counsel, they will not report the locations in the registry, and that makes sense. You don't want all your federal agencies listed on a website. So regulations such as Part 4 require some sort of communications and agreement for information for flow to occur between the state and the federal governments, and GSA has assured us they'll help us provide the necessary data on a case-by-case basis. We're very pleased with that. Let's take a look at tracking compliance in our healthcare facilities related to Subpart 4-2. The environmental assessment form has been very, very handy. So the use of the EAF predates the regulation, as I stated, and it was developed around 2005 and implemented in 2009. About 30% of the EAFs we've received have been received since the permanent regulation was put into place. 104 out of 305, plus those in 2016. We've estimated that we had about 200 EAFs at the time of the emergency regulations were enacted, and we've moved up from there. So basically, we're getting a lot of data, but you have to understand that EAF is requested for facilities that have disease, and that's why it's limited. We have roughly 800 hospitals and nursing homes in the state. If we take a look at this next slide, and there's a little error on the bottom, it didn't fit. The resubmissions requested were 67 for your information. The resubmission numbers were 59 and percent was 88, and there's one more row missing, resubmission sufficient. The number was 24, and that represented 40%. So you can see in our first round where that red 2.5 is that what was considered sufficient was very, very low. We had to send them back with a letter explaining what was the problem, and they resubmitted, and we had an 88% response immediately, and then we had basically 40% of those resubmissions were sufficient. And we continue to work with facilities on getting their sampling and management plan in good shape. Another thing that we did was partnering, and in this case it was with CMS. In particular, our Office of Primary Care and Health Systems Management, which is our hospital and nursing home program, has worked diligently in making sure that their facilities are compliant with the regulation in the CMS memorandum. This is covered in the subsequent slide. Staff made a presentation at the Special Pathogens Lab workshop in Pittsburgh and discussed the presentation with the Joint Commission's new Director of Infection Prevention and Control, and they're very much in favor of the approach to Subpart 4-2 and in favor of checking for compliance in New York State hospitals. Excuse me. CMS requirements, well, very simply, they've been covered, but if we look at this, the bold in the third bullet, you have to conduct a facility risk assessment, develop and implement a water management program, and specify testing protocols. This is CMS memo made our healthcare facilities carefully scrutinize the regulation. New York State Healthcare was lucky because the SMP is a water management plan, or at least has elements of that, and the regulation made them compliant with the guidance in the CMS memo. How did that happen? If you do a comparison of the CMS memo to Subpart 4-2, the risk assessment is roughly equivalent to our EAF, which is the equivalence of Subpart 4-2 in the second column. Develop and implement a water management program, which is essentially putting together the sampling and management plan that we discussed. And finally, specifying testing protocols. Our Appendix 4B says, here's the interpretation of data and the response to Legionella culture results. So there was a good match, and it put our hospitals and nursing homes in a very good position. OPCHSM also has their own enforcement, and there are certain issues that they can talk about deficiencies, and in the yellow on here says where they would issue a citation. So do they have a sampling and management plan? If they don't have one, there's going to be a citation. The next big red arrow on the left shows, does the facility have an environmental assessment plan? If they don't, there's going to be a citation. Is it updated? If it's not, there's a citation. And finally, does this building have a cooling tower, and does it have a maintenance program in plan? And that's another opportunity for a citation. But the difference here is that OPCHSM is doing their regular inspections in nursing homes. So this is a visit during a non-disease situation. When we get into our environmental health program gets into a hospital or a nursing home, it's usually during disease. So they're actually being looked at both during disease events and during quiet time. So they're required to report their 30% exceedances to the health department, and these are the data for the last few years. The first bar is the last quarter of 2016, and then you can see that there are 4 quarters of 2017 and 3 quarters of 2018. And most of the occurrence occurs in the second and third quarters. But one thing you can notice is that it was a lot higher in the first full year of the permanent regulation and a lot lower in the first 3 quarters of 2018. Was that a positive impact? And I think it's way too premature to say anything, but a couple of years will help us determine if there's been a positive impact in reporting exceedances and the exceedances actually going down because of the regulation. Because of all of this that was going on, we had to offer some solutions and be very brief on these solutions. One of the things that we did was we are migrating all our paper forms to an electronic format. We are hoping to have that done by spring of 2019. It might be this summer of 2019. But both the EAF and the sampling and management plan will be turned into an electronic format, and they will be required to file it with the New York State Department of Health. Another thing we learned was that we needed better travel information, so the questionnaire that our nurses use in the counties has a lot more local travel. And we also like to ask questions about other exposures, as we try to avoid the cooling tower myopia. And those other exposures can be water main failures and repair, scheduled water main replacement or distribution repair work, routine water main flushing, and even local jackhammering and pile driving can disturb the piping. Water used to suppress dust at a construction or a demolition site. Recent fires can roil up the distribution system, decorative fountains, and you've heard a lot of these in many other presentations. So we have expanded the questionnaire to make sure that we can cover as many of the potential exposures and then move on from there. It's not just cooling towers. Some other solutions are we've got a very comprehensive program website. We've got templates for certification and the management plans. We have the registry reminders, emails. We've had numerous training sessions, and outreach and education materials are being offered on a regular basis. This is just an example of one that's hot off the press. When we do visit a site, whether we're just doing a spot check or responding to a non-compliant situation, we'll hand out this Owner's Guide to Legionella Regulations, and it briefly outlines how to follow the regulation very simply. And the bookmark is the briefest of them all. It's a very short summary of how to be compliant with the regulation. Questions are going to be later, but there's an appendix here, and it links you to the resources that we have online. All of these blue links are hot, and you should be able to see them at your leisure and look at our templates and look at the tools we've given to our stakeholders. And you could also look at our general public resources online. So now I'd just like to turn it over to Marc Lechevalier and his discussion on microbial risk assessment models. Thank you very much.
Thanks, Dave. Really interesting. So just disclose, as Grace had said, I'm a member of the National Academy of Science panel on Legionella. And my other disclosures, I am working with IDEX to do an evaluation of their Legio alert, although we're not talking about that study here today. But it's kind of a starting point because we end up having 12 sites evaluate that method for monitoring distribution systems. And we've heard about building water systems, about cooling water systems. Now, I really want to talk to the public water systems in the audience. And in recruiting sites for this study, we had many of the leading utilities, normally at the forefront of monitoring, declined to participate in the study for a variety of reasons, but at least some went to their state agency, said we're interested in doing a study of Legionella, and the state wasn't quite so enthusiastic about that. In fact, one said, we're essentially going to shut your system down if you find Legionella in your system. And so having guidelines on responding to low levels of Legionella in systems is really critical to moving forward as water utilities have a better handle on Legionella in their water systems. And so we look for regulatory guidance. And of course, for public water systems, Legionella is regulated under the Surface Water Treatment Rule, which sets an MCLG for Legionella. Of course, that's an MCL goal, and otherwise expects to control Legionella as part of the treatment technique of filtering and disinfecting surface water supplies as a anticipation that would control Legionella in water systems. As we've seen from the increase in waterborne disease, now all of those are related to outbreaks in building water systems. Can only think of one outbreak that was related to Legionella in a cooling tower in a public water system. Still, we don't have any direct guidance for Legionella outside of compliance with Surface Water Treatment Rule. And it was pointed out earlier, CDC doesn't set regulations, but at one time recommended that less than 30% of samples in healthcare facilities should be positive. And we heard a presentation in the first webinar of this series that covered some of the background on that. And CDC has come out and said, well, there's no known safe levels for Legionella, in part because we don't know what it's not that any level of Legionella is a risk, is we just don't know at this point what is a safe or unsafe level. Although I'm going to talk on this presentation of how that science is moving forward and where we could be making these decisions, hopefully in the not too distant future. So OSHA has historical guidelines for occupational exposure, and there are a number of international guidelines that I'd like to talk about. For example, OSHA, which makes the point of saying that they no longer recommend these guidelines, but historically these are guidelines that have been in place, so it may be a place where people looking for some guidance might consider in developing their water safety plans, and it had these kind of recommendations. So an action level, if your monitoring showed levels in cooling towers or domestic water at these levels per milliliter, they might take action to clean and treat their system, and if they exceeded the action 2, they would take prompt efforts to reduce employee exposure. And you can see the cooling tower number was matched very well with the guidance provided in New York State. The European Union is working also on draft building guidelines, and here their recommendations are shown, so that the goal should be to have treatment with no Legionella detected. And as we know in water systems, for many systems that routinely monitor for bacteriological quality in their water, many times none are detected. But it also shows that if low levels are detected, less than 1 per milliliter, it would encourage the building manager to now check their water management plans and talk about the other water quality values. Are there disinfectant? Are there other control procedures in place? If they're in place and working properly, then occasional low-level detections or low-level concentrations of Legionella may not be unexpected if the system is otherwise operating properly. And then when they get to higher levels at 1 to 10 per milliliter, and this would be in the potable water system of a building, then they would resample and implement treatment if that continued to occur. And then at high levels, then that would trigger an immediate review of their disinfection system. And just to show you a snapshot of how other countries are implementing these similar kind of guidelines, I showed you here are the levels of which a variety of different countries, and I have the United States with the OSHA guidelines included here. If the levels are below anywhere from 0.1 to 10 per milliliter for general populations, that would be considered effective maintenance. Now, what I like about this in healthcare facilities, they may have different guidelines where you have a high concentration of susceptible population. You may want to be more stringent, and then generally, they, for instance, Germany may have levels less than 1 per milliliter in general population, but in healthcare facilities, they're looking for 0 results. And then in this kind of intermediate time, when they're starting to trigger to take some actions, the levels are now exceeding that, running from 1 to 10 or 1,000 per milliliter, and again in healthcare facilities. So here now they're kind of getting in this this danger zone, and they're reevaluating the water management plans. They're looking at their disinfection processes and following up on any kind of testing. And then finally, we're in that red zone when we exceed these trigger levels, and now the facilities are taking immediate actions. What I like about this concept is that many countries, including the EU, have guidelines for Legionella in building waters. And as we heard earlier here, we don't have any set guidelines here in the U.S. It's up to the water management team to do this themselves, and they would obviously might be looking for help and guidance. And I like the fact that these guidelines recognize that water of acceptable quality can have low levels or low occurrences of Legionella, so it doesn't have to be 0. It may occasionally give a hit or two, as long as the rest of the water quality parameters are functioning, their water management plan is functioning properly, and the water quality parameters are within target. Occasional Legionella hit or two may not be unexpected. And these trigger levels can be established to take actions to minimize Legionella, and that different action levels might be established for high-risk populations. Now, currently, there's at least a 1 or 2 log variation in these guidelines. So as we start to think about this kind of approach for the U.S., we want to try to evaluate that variation. And it's important to emphasize these guidelines are not generally risk-based, that they represent the operational practice in their specific region. So one reason that Germany may have a different number than Australia is because of the kinds of systems, the kind of environment that they have in those areas. What's feasible and practical to achieve in Germany may not be so feasible or practice in other parts of the world. And actually, that's very similar to many drinking water regulations, also take into account what's feasible and practical. So let's look at the other question: is science helping us to set these guidelines using QMRA models, quantitative microbial risk assessment models? And there are a number of these. In total, 18 different models exist in the literature. Armstrong and Haas developed a model using outbreak data, so it is taking into account the various sensitivities, susceptibilities of populations exposed to Legionella. And they reported that Legionella content, for instance, in a spa water was over 10 to the 4th CFU per mil and that matched the clinical infection rate of about 5 times 10 to the minus 3, and you can see the confidence range on this slide. They also then took that model and evaluated other risk estimate exposures for other outbreaks, and they range from about 600 per mil for an outdoor bath, about 800 per mil for indoor pool water, and 1,300 per mil to again over 1 times 10 to the 4th for another spa outbreak. So looking at these risk models, it takes a fairly high concentration of Legionella in the water to trigger these kinds of risks, and even then, those risks might be in the range or slightly below our target for what's been used as an acceptable standard for drinking water. And this conceptual risk model starts with considering the Legionella in the water supply. We know that Legionella are in amoeba inside the biofilm, and they may be released into the water. They become detached and then contain in aerosols, where then a person would inhale them, and those aerosols have to be small enough so they'd be deposited deep in the lungs to cause an infection. And so it's actually possible, and in this paper by Schoen and Asphalt, they started with what concentration in the lungs would be required and back calculated to what would be the concentration of Legionella in water that might be resulting in a risk of infection. And their critical range is in the same ballpark as the other QMRA models, with about 10 to the 3 to 10 to the 5 CFU per mil for a 15-minute shower. Now, recently we participated in a project. The lead author was Carrie Hamilton, who was a postdoc with Dr. Charles Haas at Drexel University, and looking at the risks for Legionella in reclaimed water when that water was used for different applications. And here's the risk of 6 different utilities, the Legionella in 6 different utilities for water use for toilet flushing. And the concentrations of Legionella range from about 0.2 CFU per mil, with 5% of the samples positive in utility 33, up to 11 CFU per mil, and 81% of those samples positive for culturable Legionella in utility 4. And we've placed that at a 10 to the minus 4 risk model. We can see that those concentrations of about 10 per mil or lower for an application of toilet flushing would meet a 1 in 10,000 risk of infection. Also, the same kind of a model was used for spray irrigation, and we see roughly, now this is for all that data put together, that the spray irrigation, also the mean of that risk was generally in the 10 to the minus 4 range based on culturable results. And for cooling towers, though, that risk was higher because cooling towers produce more aerosols in the smaller range than you would have from just sprinkler systems. And so this would indicate that if you're using reclaimed water for cooling tower, then additional treatment would be required, much as Dave has already outlined. So the takeaway from the consideration of the risk models is that there are lots of different risk models available to assess the risk of Legionella, and they have assessed various routes of exposure, including showering, irrigation, toilet flushing, and others. The models generally point to a low risk of infection when Legionella densities are low in the range of 0.1 to 1 per mil. And recommended levels of Legionella could be lower for situations where fine aerosols are produced, for example, in cooling towers, or when there are susceptible individuals might be exposed. And therefore, it would be possible to do a meta-analysis of these models to develop guidelines for Legionella in U.S. water systems. So in the development of that project, where we're working with 12 utilities to monitor Legionella in distribution systems, we worked with one state, that was the state of Washington, was very progressive and very supportive of these efforts to monitor for Legionella in water systems. And we developed these guidelines for those 12 utilities participating in the study to respond to positive samples. And so first of all, we should speciate or serotype any positive results. So we know, are we dealing with a Legionella pneumophila? Is it Legionella pneumophila serotype 1, which is the cause of most of the waterborne outbreaks? And then we should compare the water quality for the site compared to historical levels. And this gets back to the comment early on. We really want to put the Legionella data in the overall context of the information the utility already has. What are the normal chlorine residuals? What are the temperatures? Determine if any anomalies exist in that sample that would account for any positive Legionella results. And we should repeat any positive samples within 24 hours just to validate that and to understand the frequency of occurrence of Legionella at that site. And if the repeat sample is negative, then the site should resample according to our study protocols. But a second positive should trigger, and we recommend it here, like a level 1 total coliform assessment. So kind of was mentioned by other speakers, is there something going on in the system? Was there a main break? Was there flushing? Was there lapse in treatment? Was there a turbidity exceedance? Try to understand what was going on in the system that might relate to the detection of Legionella in the water system. And if the levels of chlorine are low, to flush that system, or if that sample is collected from a reservoir, consider draining and or boosting the chlorine within that system. And then ultimately moving forward, it would be important to evaluate trigger levels to establish corrective actions. And we don't have those today. We could default to like the OSHA or the EU guidelines, but in development of some kind of guidance for U.S. water systems, these trigger levels could be based on concentration, like in the guidance, or they could based on frequency of occurrence. For example, the trigger level, the action level for coliform bacteria is a 5% occurrence. Could we set something similar to that for Legionella, knowing that as long as other water quality parameters are in place, we may end up having some low level of detection. But if there are multiple detections and high densities, then that could trigger the utility to communicate and collaborate with their public health authority to take additional actions. So there is a lack of guidance for Legionella in systems, and for some cases, it's inhibiting water operators from monitoring their systems. That may want to look at their systems and ask the question, is their current water management plan? Because really, for public water systems, the regulations we operate under now, surface water treatment rule, the groundwater rule, other best practices in cleaning and flushing their system, cleaning their storage tanks, all the things that utilities do now to manage water in their distribution system, ask the question, how is that being effective for managing Legionella? And they may want to monitor that for that, but with no kind of guidelines, it may be inhibiting them. I've showed you that ample information is available to provide perhaps non-enforceable health advisories. So while we may not be available today to set MCLs or regulations, we could provide framework, as what we did in consultation with the state of Washington, provide some kind of guidance if you're going to monitor. Here would be the kinds of things to do. And they could be updated, revised as additional data become available. So it's not necessary now to have the perfect answer, but have some kind of framework that allow utilities to start and building water managers to start monitoring and get that information about the performance of their water management plans. So in this project, I would, this is my opinion, suggest to convene a work group of state and federal regulators to develop these guidelines. And in fact, we're currently in dialogue with the Association of State Drinking Water Administrators to move along this kind of recommendation in 2019. So with that, Grace, I'm going to turn the microphone back to you, and I think we have some time for questions and answers.
Okay. Thank you, Mark, and then thank you to our presenters today for the great presentations. We'll go ahead and take some time for the questions now. Just a reminder, please be sure to type your questions into the question box on the left side of your screen. So there are several great questions coming from the audience. I would like to start with the Bill. So Bill, this is a question to you. So your public comment on Guideline 12. So how do you get on the list to review and comment?
Okay, good question. You can go to the ASHRAE website, and they've recently really streamlined it to make it much easier to navigate. Basically, you can go to a search block and just put standards or type the word guidelines, and it'll take you to a page for any and all standards and guidelines that are currently under public review. Then there's just a pretty easy menu that'll take you to that one. This one again is ASHRAE Guideline 12-2000R. The R stands for revision, and you'll see the dates. It was a 45-day public review, so I think it started, somebody do the math for me, like November the 2nd, but it does end on December the 17th. So we've got almost 2 weeks, got 13 more days left where you can render comment to it. But it's all very easy to navigate, and it's menu driven, and it's pretty easy to do.
Great, thank you. Well, next question goes to Dave. So are the Legionella cultural results that you showed from your slide, your presentation slide, it's just the requirement for the New York or the nationwide? Dave?
Sorry. All the requirements that were shown in the presentation for Subpart 4-1 and Subpart 4-2 are for New York State, excluding New York City. New York City has their own regulations, so any thresholds that you saw in the presentation are for the 57 counties outside of New York City.
Well, this another question to Dave. So that you also said in your presentations, the environmental assessment must be done so when the potable water system is installed or updated. So do you foresee that the environmental assessment and other requirements will be adjusted to account for the non-potable water supplies which are not regulated in the same way that drinking water is? Dave, are you on mute?
Yes, I'm having a little problem with my phone, sorry. The one thing they have to realize is that the presentation, Subpart 4-2, refers to healthcare facilities. So it doesn't refer to buildings in general. I don't foresee water reuse in hospitals and nursing homes in the near future because of some of the potential risks. That being said, however, water reuse is becoming a lot more frequent use, and in New York State, we've actually been called in as DOH to look at some water reuse, more for things like watering plants and golf courses, and we've had a couple instances where there were cooling towers involved with water reuse, so we had to work on it on a case-by-case basis. But as far as healthcare facilities, I don't see that. Now, if we do end up having a subpart that's related to general purpose buildings outside of the healthcare facilities, there's always the capability of writing that subpart and having this kind of information included in it. But again, I don't foresee that in the very near future.
Thank you. Well, this question goes to the Mark. So this question is related to the non-potable water reuse. So is there any research on the impact of the municipal non-potable water reuse or on-site water reuse on the detection of the Legionella in the effect to the plumbing? Is there any research on it?
Yes. And so the results I presented came from a Water Reuse Research Foundation, now part of the Water Research Foundation report on Legionella in reclaimed water systems, and you should be able to find that on the Research Foundation website. We did find Legionella in reclaimed water systems. The first part of that study was a survey of 19 systems, and then the follow-up and more intensive monitoring was of 6 systems. I showed some of that data. Now, these systems were chosen because, on the first part of monitoring, showed that they had Legionella in the systems. So that shouldn't be reflective of all reclaimed water systems. And in fact, there are now a variety of different reports from the Water Reuse Research Foundation, now on best management practices and on managing reclaimed water systems. But the point of that risk assessment is, despite the fact that it's finding Legionella in those systems, when they're applied for toilet flushing or spray irrigation, or the kind of applications that are used for reclaimed water, even though Legionella is detected, the risks of illness are low from those kinds of applications. Still, the point of that research is to point that that reclaimed water systems can focus on this and it can improve their water quality, even though the risks are low now. It's important to point out there have been I'm not aware that there have been outbreaks associated with unrestricted urban reuse reclaimed water, which was the focus of that study. Now, there's a trend towards using direct potable reclaimed water. Of course, that water is treated to much higher levels than you would see in just water treated for landscape irrigation or toilet flushing. So, and in fact, even these systems that we monitored, this water wasn't necessarily used for those applications. We just used that data to illustrate if they were used for those applications, given the concentration of Legionella found, what would be those kinds of risk assessments.
Thank you. Well, next question, again, is going to the Mark. So it's also still, it's related to the reclaimed waters. So is Legionella the most common with the reclaimed water, or is it still the major problem with the drinking water quality water?
So our interest in doing the study on reclaimed water is because based on some prior studies and published literature, Legionella can occur in and again, reclaimed water is a whole range of different waters. It's not just one thing, kind of like drinking water generally has to be a quality that you can drink. Reclaimed water can be everything from, slightly slived sewage to, direct potable reuse. So it's quite a range of different water qualities. The water that we were testing is what we called unrestricted water for urban reuse. So that would be water that was sprayed on parks, not used for potable supplies, but used in urban environments. And Legionella can be found in those. We did the study on reclaimed water, not just because we weren't uninterested in other supplies, but we could find Legionella virtually in many of the samples that we processed. But we're interested in developing the risk models and risk applications and the control procedures so that we could apply that to drinking water as well. So, it's Legionella in water and water management, whether it's in a building or a distribution system or reclaimed water, we wanted to get the data and get the experience in managing those occurrences so that we could apply that learning to other applications.
Thank you. Next question is for Laura. So why are the cases of the Legionella disease continuing to rise? And are other countries seeing the same rate of increase of the Legionella as the U.S.?
Thanks. Those are great questions. And, you know, I think as with any good public health question, the answer is likely multifactorial. I think that we don't know the answer why Legionnaires' disease continues to rise. It makes sense that there is increased susceptibility of the population, at least in the U.S., with aging U.S. population and more patients on immune-suppressing medications, more people at risk. There is also reason to think that there could be more Legionella in the environment with warmer temperatures, aging infrastructure, as we discussed, water-saving building modifications, things like that. There is probably also an element of increased ascertainment, either due to better use of diagnostic testing for clinical cases of disease, better surveillance, better reporting, all of that. So it's probably a combination of all of the above. As far as internationally, it's a little hard to say. Surveillance is conducted differently in different countries, and we at CDC are only responsible for surveillance of cases in the U.S. And so there's really not a benchmark for comparing, but I will say anecdotally at international meetings and in the literature that increases in reports of Legionnaire's disease are occurring, you know, everywhere that perform surveillance for Legionnaire's disease. You know, not every country even performs surveillance for Legionnaire's disease, but where they are also seeing increases. And I think grappling with the similar questions of why.
Thank you. Next questions for Clarissa. So is there any reasonable and reliable way to detect the level of Legionella in the finished drinking water at the water treatment plant?
That is a great question. So we assume that in water treatment plants the burden is going to be very low. So we would expect that a testing laboratory would do some sort of method to concentrate and enhance the Legionella detection. But that being said, I think the question is there a reproducible test method? And I think that all has to do with the methods. So the point I was trying to kind of convey with the slide with the 3 plates is that under the elite program, all of those methods of detection are valid. 2 of them would result in a passing score. I think we remember Dr. Zawolski talking about how they require ELAP certification for the labs that test, and part of the certification process to get ELAP, they are an actual accrediting body. They do inspections. They specify the method. So if you use an ELAP lab, you're going to have a lot more consistency in the enumeration. Similarly, if you were to use an elite lab and specify that they were to use the same methods, you would also have more reproducibility. So in summary, it's not necessarily that one method is better than another, but you really have to control for the methods if you're going to interpret the results due to enumeration.
Awesome. Thank you. Well, next question is for Dave. So in the New York City Subpart 4-1, what is the definition of the cooling tower?
So it's actually New York State, and our definitions, both in New York City and New York State, are very close. We define it, and I'll have to read this right out of the regulation. The term cooling tower means a cooling tower, evaporative condenser, fluid cooler, or other wet cooling device that is capable of aerosolizing water and that is part of or contains a recirculated water system and is incorporated into a building's cooling process, an industrial process, a refrigeration system, or an energy production system. And that's our definition. And basically, there's a follow-up. Are there any exceptions? based on size, and basically we've looked at everything from cooling towers associated with dry cleaners to those at power plants. There are no exceptions. However, there is a capability for any place to apply for a variance or a waiver. Variances have expired basically unless it's a new facility, a new tower, because all that is allowing a facility time to come into compliance with a particular subpart. The waiver, on the other hand, is a very specific application saying that the regulation doesn't apply to us, and they would have to supply justification, and then based on technical details, we would either grant or deny the waiver. So right now there are no exceptions, but you can apply for a waiver at this time.
Thank you. There's several general questions to any speakers to answer the questions. So the one question is, if there is a federal standard for the building water for Legionella, who will be the responsible for maintaining compliance? Anyone would like to answer these questions?
Well, this is Bill Pearson. I think I can render what I would suspect happened if there was indeed a federal compliance, just like there was a city compliance requirement and then a state compliance requirement in New York, then it would be that entity. So my assumption would be if the federal government came out with a requirement for compliance, they would also they would be the authority having jurisdiction, and they would need to have would be responsible for I guess monitoring the compliance.
Thank you.
Yeah, this is Mark LeChevalier.
Yes.
I'll just kind of add color to that. One of the reasons this is a challenge, and this is where the National Academy of Science panel is looking at, is because drinking water has authorization from Congress to develop regulations for public water systems. And typically that responsibility is up to the point of where it connects into the building, either the meter or the property line. It varies somewhat. But once the water enters the building and in the building system, the public utility doesn't have control over how that water is managed within the building system. So this is a challenging question, because the federal, and kind of why Bill said that EPA would control the public water systems, and it would go more to the building code. Perhaps like in New York City, it would be the health department. But it's not clear where the path would be, that we would have a federal standard that necessarily would apply to building water systems, because that's individual, properties. So it's a good question, and one where there's a lot of head scratching to figure out how can we improve public health safety, given the kinds of jurisdictions we have. It would largely fall under plumbing code and building systems. In some cases, like we see with the CMS, or could be insurance companies for large public buildings, they're telling the owners, you have to have a water management plan, because not having that increases your insurance liability. So there may be a variety of different ways to do this, but it's not a clear sight how the federal government would be regulating public buildings.
Okay.
Hi, this is Dave. I just want to add something to what Mark had to say. If you look back into ancient times and look at the original surface water treatment rule, the target of that was microbial control, and the microbes mentioned in the preamble to the rule was Giardia, and that's basically where our disinfection tables came from, and our CTs, which is our concentration and contact times for chlorine disinfection, viruses, and the third organism that was mentioned was Legionella. But you have to keep in mind the surface water treatment rule was a treatment performance rule. So if you have a treatment plant and you have unit processes and they're functioning right according to the rule, then you've done everything you need to do, and you can send the water into the distribution system. Now, I realize, everybody should realize that there have been many iterations of the surface water treatment rule, the interim enhanced surface water treatment rule, LT1 and LT2, and it's kind of shifted a little bit to more resistant critters such as Cryptosporidium in addition to Giardia and viruses. So the treatments are targeting much more resistant organisms, but the outcome is the same as microbial control. So although it's not really regulating the organism, it's actually saying here's how you should treat to eliminate these organisms. It's been in place for quite some time.
Thank you, all of you. Well, looks like we covered most of your questions. The questions we could not answer during the webcast will be answered by email. Before we close this webcast, and I have one announcement to share with the audience. The Water Research Foundation Project 4664, Customer Messaging on Opportunistic Pathogen in Plumbing System, the project final report is now available on our website. This report is open to the public. So we also have a schedule for the project webcast on January 17, 2019. So we haven't opened the webcast registration yet, so please check your inbox for the future webcast announcement. Well, I would like to thank each of the speakers who are willing to present and share their knowledge with the audience. And thank you for joining today's webcast, and enjoy the rest of your day.